Welcome to the second part of the lesson, which deals with graphing of other trig functions. The first video discussed tangent and cotangent. This video is going to discuss cosecant and secant. Now you can kind of see on this graph here, and it looks kind of like a gray line here. That's what the dotted line would have been. So I'm going to kind of fill that in. That's the blue line here is our sine function, and we're used to that sine function. We saw it in the last section. Now what we're looking at is the cosecant, and again, cosecant is 1 divided by the sine of theta. So if sine is x, this becomes 1 over x. So again, when x is 0, we're going to end up with asymptotes. So we end up with these asymptotes here and here and here. And you can see those are all the points where the sine function is crossing and hitting 0, because we're dividing by 0 there. Cosecant here actually has a full cycle of 2 pi. It is this part of the graph, this kind of downward U, and this upward U. Similarly for secant, secant again is 1 divided by cosine of theta, which was 1 over y. So again, anywhere that y value on the unit circle was 0, again, that's going to correlate to the points where the graph is crossing here, where our cosine graph is crossing is going to cause us an asymptote. So you can see they have the exact same shape, they're just shifted. Same thing that we had before with sine and cosine. I'll draw this cosine function in a little bit better for you. So just like sine and cosine were the same thing, only shifted, secant and cosecant are going to be the same shape, only shifted. Again, for this, period is just going to give us a steeper U. If the amplitude is greater than 1, if it's between 0 and 1, it'll be a little bit flatter, a little bit more level. It will also shift us on the axis. Notice that our graph is crossing, these coincide. Again, this is 1 over x, so if you have 1 divided by 1, you get 1. So our secant and cosecant graphs are going to be touching those sine and cosine curves. So that will also affect our amplitude. Our amplitude is going to tell us kind of where the lowest point of that U shape is. So again, period for secant and cosecant is the same as it was for sine and cosine. It's 2 pi, or if we have to do an adjustment to the period, it's 2 pi divided by b. So let's take a look at an example. So for this example, we're going to look at secant. Again, we don't have any stretching factor here. We just have a coefficient of 1 on secant. So it's going to line up with cosine of 2x. We don't have anything to stretch it there. Our period in this case is going to be 2 pi over our 2 here. So we just end up with pi. In this case, we don't have any horizontal shift or phase shift because it's just the 2x there. There's no additional factor. So our period is pi, meaning that our starting point is going to be at 0. So if we draw our table here with all of our values, then, like I said, we're going to start at 0. Again, if you kind of want to do the thing by cutting things in half, you would end at pi, so halfway between would be pi over 2. Halfway between 0 and pi over 2 would be pi over 4. Halfway between pi over 2 and pi would be 3 pi over 4. And then you've got your quarters that you're looking at. Again, we're comparing this secant of 2x is going to be 1 over cosine of 2x. So we're really looking at the cosine graph. And we can put that on our chart as well if we want to. We can say, okay, let's graph cosine of 2x. So cosine of 2x always starts off at, for cosine it's an amplitude, for secant it's just a stretching factor. So cosine we would start at 1, and then we would go down to 0, and then down to -1, and then back to 0, and back to 1. Again, that would be a full cycle, so we'll kind of draw cosine in there. If this is pi here, then again, like I said, cosine, we're going to start off at 1, go to 0, go down to -1, back to 0, and then back to 1. So that would be our cosine function. And then if we're looking at secant here, then secant would be the reciprocal of all of these values for cosine. So 1 divided by 1 is 1. 1 divided by 0 would give us an asymptote. 1 divided by -1 would be -1. 1 divided by 0 again would be our asymptote. And then 1 divided by 1 would be 1 again. So again, if we kind of think about this, we are going to have our asymptotes here where we're crossing. Again, 1 divided by 0 is going to be that undefined. And then we're at 1 here. We go up to the asymptote. We're down at -1 here. We've got that U-shaped piece here. And then at pi, again, we're at 1, and we're going up to the asymptote at 3 pi over 4. Again, if we want to full 2 cycles, we would draw the asymptotes in at 5 pi over 4. So this one would go up. And then we'd have another one at 7 pi over 4. We'd have our other U-shape down here. And then we can either kind of go backwards on this one that we started, or we can go forward here. Either one of those will get us our 2 full cycles. So again, it's the reciprocal of cosine, so if you want to draw that cosine column in first and then just do the reciprocal of all those values, that's fine. It's kind of an easy way to remember it. And then you can kind of graph the points in from there. Okay, let's take a look at a cosecant example now. We don't have an amplitude here, but this is going to tell us that we are flipped. So we don't have a stretching factor in this case, and cosecant doesn't have a amplitude because, again, these things are going off to infinity. So we're just looking at our stretching factor now. But period, we got a coefficient of 1 in front of the x, so 2 pi over 1 would be 2 pi. Phase shift we are going to have this time, so we're going to shift horizontally because of this. Phase shift is negative pi over 2, and then again coefficient in front of x is 1, so we divide by 1, and we're left with pi over 2. So again, this is our starting point, this is our horizontal shift, and if we want to find our ending point, that is just going to be our starting point plus our period, so pi over 2 plus 2 pi is going to give us 5 pi over 2. So again, if we want to make our table here, we can go back to the fact that cosecant is 1 over sine, so we've got our x values, we can graph sine of our function, and then we can graph our cosecant function. So x, again, we're going to start at pi over 2, we're going to end at 5 pi over 2. So again, if you want to do the halves method, halfway between 1 and 5 is 3. So this would be 3 pi over 2. Halfway between pi over 2 and 3 pi over 2 is just pi, and halfway between 3 pi over 2 and 5 pi over 2 is 2 pi. You can also go back and do the quarter methods. A quarter of 2 pi is pi over 2, so you just add pi over 2 consecutively until you get to that 5 pi over 2. So again, sine, we always start at 0 and go up to the amplitude. In this case, it's flipped over with an amplitude of 1. So we're going to go to -1, then back to 0, then 1, and then 0. And again, cosecant, we don't have an amplitude on because it goes off to infinity. We just take the reciprocal of those sine values. So 1 divided by 0, again, is going to give us our asymptote. 1 divided by -1 is -1. 1 divided by 0 is again an asymptote. Lots of asymptotes here. 1 divided by 1 is 1, and 1 divided by 0 is an asymptote. So again, if you draw the sine function in, kind of label, so we'll make this pi over 2, this pi, so forth and so on. This can be a value of 1. So again, at pi over 2, we're starting at 0. At pi, we're going down to -1 because it's flipped. At 3 pi over 2, we're at 0. At 2 pi, we're up at 1. And then at 5 pi over 2, we're at 0 again. So again, if you kind of draw in your sine function first that you can then flip off of for the cosecant function, again, anywhere we're crossing at 0 is going to give us an asymptote, and that matches here with our notes here that say that we have asymptotes at those points. And then again, anytime it's at a amplitude for the sine function, it's just going to be the touching point for the cosecant. So we've got those U-shaped here and our U-shape there. Again, that gives us one cycle. If we want to go back and do the second cycle, then we would go backwards. We'd go up here at 1, then down to 0, then down to -1, and then back to 0. And again, we've got our asymptotes anywhere we're crossing. And we've got our U's kind of touching at those amplitude points on sine. So this is how we graph secant and cosecant.